for number 3, we're going to use the method of Lagrange multipliers to solve an optimization problem. So first thing you need to do is figure out what is the constraint function and what is the objective function. Upon reading the problem, we can see that we can only spend $200,000 on labor and equipment. So if X represents the $1,000 amounts on labor and Y is the amount of dollars we can spend on equipment, then the sum of those two should be 200. So the first thing we're going to write down is the constraint function. Remember, we used the notation g of x, y to represent that. So g of x as y should be equal to x plus y equals 200. The second thing I'm just going to do is write down the objective functions, which is the q function. Make sure that you don't copy things wrong. The next thing we do is use the method of Lagrange multipliers, which says that the derivative of the objective function with respect to x should be equal to some constant lambda times the derivative of the constraint function with respect to x. If you do that algebra, you will get, for q sub x, you will get 60 times, and you bring this 0.4 down from the x, and you subtract 1 on the power to get x raised to the negative 0.6. Y in this case is a constant, therefore you leave it alone, you don't do anything to it, it just sits right next to it. On the right hand side, you're going to write down lambda, and you're going to get derivative of a g with respect to x. But in this case, it's just equal to 1. So we simply just get lambda. If you clean it up a little bit, so using algebra on the left hand side, you get this following equation. I'm going to call this equation number 1. Similarly, we're going to do the partial with respect to y. The algebra says that on the left-hand side, the q sub y would then be 60 times, you bring the 0.6 down from the y variable, and then subtract 1 from there, you get negative 0.4, and the x in this case is the constant, therefore we're going to leave it alone. On the right-hand side, you get lambda times the derivative with respect to y from g, but that's also equal to 1. So clean it up a little bit, we'll get the following equation. And we're going to call this equation 2. The next thing we observe is that both equation 1 and 2 represent lambda. So we're going to set them equal to each other and then get a relationship between x and y from that. So this is simply just rewriting equation 1 equals equation 2. What's tricky about what to do next is you have to think of an appropriate algebra to perform on this equation in order to clean it up to as a simple equation as possible. So after thinking for a while, I'm going to divide the left-hand side by x raised to the negative 0.6 to get rid of it. On the right-hand side, I'm actually going to get rid of the y raised to the negative 0.4. So I'm going to divide that both sides as well. So essentially, you're dividing x to the negative 0.6 both sides, as well as y raised to the negative 0.4 both sides. This will successfully get rid of the x's on the left and the y's on the right. And we also want to clean it up a little bit more by simply dividing a factor of 12 on both sides, because both 24 and 36 have a factor of 12. So by doing that, we can see that the left-hand side, after division by 12, we get 2 as a coefficient. X now disappears. For the y term, it's the power on top minus the power on the bottom, because that's one of the power rules for exponential functions, right? So you take 0.6 minus the negative 0.4, that gives us 1. On the right hand side, when we take 36 and divide it by 12, we get 3, and y goes away. The x term, then we take the power on the x, which is 0.4, minus the negative 0.6 on the bottom, which also gives us 1. So this was a very successful operation to do, because then what we have here is a function of y in terms of x. You can write y in terms of x as 3/2 times x. What's good about this is that we can use this relationship to plug back into the constraint function. So now if you go back to the constraint function, which is x plus y equals 200, we're going to replace the y term with the 3/2 x. So x plus 3/2 x is equal to 5/2 of x, which is then equal to 200 as the constraint. What this means then, we can solve for x by simply multiplying both sides by a 2/5, which then gives us 80. Hence, y is equal to 200 minus the x value, which is 80. Altogether, you get 120. So we have successfully solved for x and y. Remember to put your answers in a complete sentence. Therefore, $80,000 should be spent on labor, and $120,000 should then be spent on equipment in order to generate the largest output.